Welcome to this tutorial on AVV generation in HoloEdit and playback in Unreal. An AVV file is a new playback container developed by Arcturus that is specifically designed for use in high-fidelity scenes with multiple actors. It has numerous features that are meant to strike a balance between high-quality and performant playback in-engine. This tutorial will focus on generating an AVV file in HoloEdit, the means of controlling AVV files in Unreal, and how to take advantage of decoding options and playback settings. The AVV file format offers exceptional decoding speeds and outstanding scalability. It was designed for storing high-quality mesh and texture data as well as easy playback control. AVV reduces decoding costs, which enables the simultaneous playback of numerous high-quality actors within an engine. AVV optimizes quality by selectively identifying high-detail sections in source textures, such as facial regions, and preserving their quality while more aggressively compressing the remainder. Arcturus's other file type, OMS, is tailored for mobile and web streaming applications owing to its compact file size. However, it is less suitable for running a large number of actors concurrently. You can run significantly more AVV actors in a scene at a reduced cost compared to OMS. The trade-off for using AVV is a significantly larger file size compared to OMS, rendering it less suitable for projects where file size or rendering power limitations arise. The first step is to ingest and process a clip to achieve the appropriate level of compression. More info on this can be found in our quick start guides linked below. Here you can see our short clip in HoloEdit has already gone through the compression stages and is ready for regular export. This can also be an existing OMS you already have that has been imported for conversion. To prepare for an AVV export and take advantage of the new features, we will need to add some additional stages. First, we'll add an Analyze Texture stage, which will evaluate and choose the higher detail sections of the actor to preserve at larger resolutions. After adding a new stage, right-click next to the stage above and choose Propagate Intervals to quickly match your interval lengths. The AVV encoder will prioritize regions of higher texture detail and give them greater texture resolution. This prioritization can be seen in the debug view as color overlays. With the stage selected, you can click the View Mode toggle here to show the color overlays in the editor. In Analyze Texture, yellow tones represent detail that will be given the highest texture resolution and purple the lowest. Next is to run Generate Skeleton and Stabilize Skeleton. We'll use the joint positioning in the skeleton stage to help us track the face of the actor with increased accuracy. With the skeleton calculated, the next step is the Detect Face stage, which will analyze the actor and highlight the face geometry. This stage can be run without skeleton data, but the head joint's transform helps track the face geometry with increased accuracy. Use the View Mode toggle with the Detect Face stage selected to review the results. The calculated face prioritization area is combined with the texture analysis results you saw before, ensuring the whole face is given the best texture resolution possible. Finally, we can optionally add a Transfer Normal stage, which will pass the original mesh normal information from the source data to the output. With the stage interval selected, go to the inspector and assign your load asset data to be the source that the normals are transferred from. Once this is complete, we go to File, Export Composition, add a new export sequence, and choose AVV as the output. Using our texture analysis and face tracking stages, we can now define how much detail we want stored in higher resolution textures, lower resolution textures, and vertex colors. With the full resolution setting, we define the cutoff for how much texture information will be stored in one texture map resolution, with the rest of the color information displayed using vertex colors. The larger the percentage, the more detailed texture information is stored. If you choose multi-resolution, you can create texture resolution tiers, where the most important areas like the face will get higher resolution. The next tier of importance will get texture data stored in a smaller resolution, and so on. This is useful if your actor has patterns in their clothing instead of more flat colors. Once we have the settings where we want them, we can hit Export and move on to using the actor in Engine. Bringing an AVV file into Unreal is as easy as drag and drop into your content browser. From here, the simplest playback method is to drag the created actor into your scene and press play. Selecting the AVV allows you to adjust the playback, rendering, and level of detail settings. You can adjust playback speed to match the recorded speed using the frame rate setting. You can also slide the current frame field to review the selected clip. For more nuanced playback control, Unreal's Level Sequence Editor can drive AVV files in your scene. First, add a level sequence asset to your scene. We'll set the sequence to autoplay and loop in the Details panel. With the sequence editor open, click Add Track and add a volumetric video track. The track starts empty and we need to add an AVV section to it by clicking here on the Add Volumetric Video button. Right-click the created section, go to Properties, and assign the AVV actor in your scene to the track. From here you can move the section around to offset its playback timing and length. Now you're ready to populate a crowd scene with numerous AVV humans. Arcturus is excited to present the AVV format and can't wait to see what scenes are created using it. We have full documentation available for all of these features on our website as well as tutorials, plus more videos on our channel.